One of the easiest chapter where most of students are confident about this.
Sir,
Okay.
I'll be back in 2 minutes.
Okay. Take the least time to cover. You can easily compare with the electric field line or electric field in general. And the best part is recently some topic are deleted from this. Earth magnetism part is deleted from. Okay. So come to the point. Magnetic field line. In this magnetic field lines, you have to compare with the electric field line. In electric field, you know electric field lines start from the positive charge and at the negative charge. Same here. It start from the north pole and end at south. Okay. So it's like north is almost like your positive, not exactly positive, but look like positive charge, and south is like negative charge. South is like negative charge. Okay. But most of the property are same. One biggest difference you can see here is magnetic field lines form the closed loop. Even inside, direction will be opposite from south to north. Outside, from the north to south. Inside, south to north. Outside, north to south. So overall, it is forming a closed loop. But electric field line do not form closed loop. That is the biggest difference. All other things are same. All the magnetic field lines arise perpendicular to the surface. Perpendicular to the surface. Two magnetic field lines never intersect with each other. Density of the lines will give you the strength of the magnetic field. All the property are same. This is the different. Second, dipole moment. Same comparison. Like normal dipole moment is charge into length. In case of magnet, whatever is the distance between the two pole, their m pole strength into L. Correct. Remember, same magnetic moment is also equal to current and area. So there are two versions of magnetic moment, dipole moment. One is current into area. Second, pole strength and length. So instead of charge, you have pole strength. Length is same. Okay. So unit of small m, which is pole strength, and capital M dipole moment are different. Understood, guys? Any doubt?
No, sir.
So
Yeah.
what is small m?
Small m is pole strength. Strength of individual pole, like charge. Like this S have some pole strength like charge, and N have some pole strength like charge. Any doubt?
Okay. No, sir.
Hmm. If you take a different shape, like normally it is the straight road from south to north and magnetic moment M. But if you bend the road and have some angle theta, you want to compare how it is different from the straight road. Then M remains same for the same straight road, and then theta will play important role in this. Though this kind of question asked less, but it just modified form ki angle play role. That's all. Angle play role. If you change the angle, overall value will. This question was asked recently in the NEET exam. I think in 2024. Resultant dipole moment. You know here dipole moment direction is from south to north. Here south to north. Same thing here. South to north direction is this. South to north direction is this. Angle between them is theta. So what is the net dipole moment? Di magnetic moment of first, second, and angle between them. Same like resultant. Example, if you take this is A, this is B, and theta between them, their resultant will be A square plus B square plus 2AB cos theta. Understood? Almost same.
Sir, I'll come back in 5 minutes, 2 minutes, sir.
Sure. Any doubt, guys, in this? Next is, if you cut the bar magnet in different way, what will be the impact? Example, if you cut from the middle, here from the middle, so length will be here L by 2, here L by 2. But if you cut from the middle, cross section wise, remember pole strength will remain same. That is the most important. Pole strength will remain same. M pole strength will remain same, but length will reduce. Okay. In this case, pole strength is same, but length is L by 2. If you see magnetic dipole moment of each part, it will be ml by 2, because pole strength is same, length is L by 2. But if you cut along the line, okay, longitudinally, then your pole strength, it's like charge will become half, but length remains same. Still, magnetic dipole moment will be capital M. Any doubt, guys? So, what is the key point in this case? If you cut the cross section, then pole strength same. If you cut along the line, then length remains same, but pole strength will be half. Next part is, everything is analogous to the electrostatic part. Everything is the analogous to the electrostatic part. How? In electrostatic, you had different charge separated by some length. Here you have different pole strength separated by some length. Here dipole moment will be charge into length. Here magnetic moment pole strength into L. Correct. In this case, if you had two positive charge or two negative charge, they repel each other. Then your electrostatic force will be 1 by 4 by epsilon naught Q1 Q2 by R square. Here, if you have two north pole, they will repel each other. Here, magnetic force, constant is different. In magnetism, constant is different. But instead of charge, you will have M1, M2 by R. Everything look like electrostatic part. Make sense, guys? In axial line, our dipole moment was 2 kp by r cube. Here, at axial, our magnetic field be 2m by r cube. So in electrostatic, we had P. In magnetism, we have M. Correct? And constant is of course different. Equatorial, minus direction and only P. Here minus direction and only M. Okay. And axial was double of equatorial. Same here, axial is double of equatorial. Tell me, guys, can you simply compare with the electrostatic? You don't need to calculate anything. Note it down and ask your question. Any doubt, guys? I told you that in the last class. And when I am asking any doubt, it means you have to read it again, understand it well. And when you are 100% sure, yes, I have clarity, then say, yes, sir, no issue. No, wow. Why there are only three people? No, Jordan, Rohina.
सर
Yes, Pratigya.
सर आप अब तक क्या पढ़ा है मैं नोट नहीं की हूँ मेरा फोन सडनली स्विच ऑफ हो गया था
हाँ, इसलिए एक बात और सभी ध्यान रखो, एवरीबडी टेक केयर ऑफ दिस कि टेक केयर ऑफ योर फोन ऑल्सो नेक्स्ट टाइम. Like you can't do anything with your phone, but because next time you will know ki that will be my like class time. So make sure ki you do better because it happened with me also, and now I am improving. That's why I can say. Bro. हाँ, ठीक. हाँ, नहीं कल का नहीं है. हाँ, ठीक. हाँ जी, नमस्ते. Oh, done, guys.
Yeah.
Next is potential in uh, electrostatic. You know, potential is equal to P cos theta by R square. And in magnetic field, it will be M cos theta by R square. Correct. If you know torque is equal to P cross E in electrostatic, instead of dipole moment, it will be magnetic moment. Instead of electric field, it will be magnetic field. Same way. Here, net force will be zero. Here also net force will be zero. Work done. Here, work done is equal to PE cos theta 1 minus cos theta 2. Same. Instead of PM, instead of EV, cos theta 1 minus cos theta 2. Any doubt, guys? Okay. Maximum work done remains same. Yeah. Yes.
So I was just saying, can you scroll up? That's it.
Are you done?
Yeah, sure.
Hmm.
wait Then
Anvita, done?
Yeah, sir.
Hmm. Next, potential energy. In potential energy, in electrostatic potential energy minus P dot E, and magnetic field potential energy minus M cross B. Same thing. If theta is zero, it is stable equilibrium and lowest energy. Energy minimum, maximum stability. Energy maximum, minimum stability. Any doubt, guys? So whatever I showed you as of now, everything was comparison with the electrostatic. If you know everything about electrostatic, it will look easy. And if you don't know electrostatic, then it will be too difficult to do. That's why magnetism and matter is too easy to do. Reason because everything is just comparison with your electrostatic. Make sense, guys?
Yes, sir.
Anybody have doubt? Let me know.
So potential energy,
Yes, potential energy minus P cross E, na?
so it's cross here and then dot. It's not
Reason
dot.
is potential energy is scalar quantity, and in scalar quantity you have dot. But when you are talking about torque is a vector quantity, and that's why in vector quantity you have cross. Understood?
No, sir. Could you repeat it again?
Just email. हेलो बहुत बढ़िया भाई साहब आपने सुना हाँ जी पहचान गया नहीं करया अच्छा
So I'm sorry, sir. The network went down.
so this was the complete comparison with your electrostatic. Ask me your question. Anybody who have doubt why,
Sir, I
how?
have a doubt.
Yes,
Like
sure.
the potential energy is scalar quantity, then
Yes.
why do we have cross product?
No, we don't have. Oh, you are right. So this is a mistake. It will be dot. I thought in general you
Okay.
are confused.
Right.
It will be dot only. Thank you for pointing this out because it was important. Any other question, guys?
No, sir.
If you don't have, now we can focus on the topic that is not directly related to the electrostatic, but indirectly it is, and it is important. Magnetism and Gauss law. You know, in electrostatic, your Gauss law is E dot ds integration is equal to charge inside by epsilon naught. Correct? This is in electrostatic. Here in magnetism, this will be zero. this will be 0. Why? Because of the current. In case of dipole, overall net value is 0. Example, if you take in case of dipole, if you take same thing for dipole, you know net charge in case of dipole is 0. In this situation, your E dot ds integration will be equal to 0. Why? For dipole only, because net charge is 0. Same thing here. If you have current loop for the magnetic dipole, it will be 0 because monopole do not exist. Correct? If you don't have one pole, example, if you have only one pole, like you have only plus m pole strength, then you will have some value. Same, if you have only one charge, either positive or negative, you will have some value. But dipole, 0 because net charge. Understood, guys? Anybody have doubt?
No, sir.
Hmm. This time period question is, I think, 2024 NEET question. They asked if you are aware about this. It was direct question. Okay, you know, in the oscillation, time period is equal to 2 pi under root L by G. This is the oscillation formula. Here, I is moment of inertia. So this L by G, according to this, will be equal to L by G will be equal to I, moment of inertia, into M into B. What is M into B, Tuhina?
Sir,
What is M into B in
um,
magnetism? Torque,
I'm not sure, sir.
because you know torque, how it is equal to PE sine theta. In magnetism, it will be MB sine theta, right?
Yes,
Make,
sir.
make sense?
Yes, sir.
So
But
your
isn't it
MB
MB
torque,
cross, like M cross B, not
yeah,
M dot B?
but no, it is not dot. That's why I wrote sine. In cross only you have sine theta, right? In dot you have cos theta.
Yes, sir, that's it. But
Hmm.
MB, isn't that like in this formula, isn't it? Uh,
Yeah, we are considering angle is 90 degree.
okay, okay.
Hmm.
Okay, sir.
MB will be equal to torque.
Okay, sir.
So you can also say ki here it will be I by torque. Okay, I by torque. So you want to see ki how time period will change. Example, you cut along the length. Length remains same. That's why time period will also remain same. Why time period is same? Because length remains same. Correct? If you cut into a different segment, like in three equal segment, L by 3, L by 3, L by 3, what will happen? Your time period will also reduce. Why? Because it depends upon length. When length is reducing, time also will reduce. It will take less time. It will move fast. Make sense, guys?
Yes, sir.
So last topic, we have different type of magnetic material: diamagnetic, paramagnetic, and ferromagnetic. And topic will be done after that. And some word related to this. First is magnetic permeability. One of the basic thing we had in the Biot-Savart law. Sarah, what is Biot-Savart law? Sarah, what is Biot-Savart law?
Sir,
Hmm.
the field strength is directly proportional to current
Hmm. Hmm.
Length and inversely proportional to the square of the distance.
Hmm.
Directly proportional to the sine angle.
Any doubt?
No, sir.
Then so my intention was not to ask anything like that. It just randomly I asked this question because new note was there. You should be extremely comfortable. If you are not like you face difficulty in recalling the point, revise. Come to the point. Magnetic permeability in case of vacuum is new note. In case of any medium, it will be new. For a given medium, it will be new. For vacuum, new note, and their ratio will be relative permeability. Jordan, what will be relative permittivity? What is the another name of relative permittivity?
Uh, I forgot, sir.
Wow. Chandana,
Absolute.
what is the another name of relative permittivity?
So relative permeability.
So, I remember it's a dielectric constant.
Yes, it is dielectric constant, relative permittivity, epsilon in a given medium, epsilon naught in the vacuum.
Vacuum, yes, sir.
Then magnetic intensity or magnetizing field intensity. As the name suggests, it is intensity. So, what is the magnetic field for a given medium? Because it is for a given medium, that's why new note in case of vacuum. Next, intensity of magnetization, ability to magnetize any material. That's why what is the magnetic moment divided by the volume. So dipole moment divided by the volume. Again, it is also vector quantity as the name suggests. Okay. So these are the few terms, not like difficult, but you will be confused. Like magnetic intensity and intensity of magnetization both look very close to each other, but both are different. One, you have magnetic field for a given medium. Medium means nu naught in vacuum. Intensity of magnetization, dipole moment per unit volume. Both look similar, but still entirely different from each other. Magnetic susceptibility you can compare with the electric susceptibility. There we had chi, here we have chi m. Correct? So you already have I, intensity of magnetization, divide by magnetic field intensity. Intensity of magnetization and magnetic field intensity. So here you have induced, here you have external. Why? Because it is a comparison of two same value. That's why no unit, no dimension, scalar quantity. It is the ratio of I by H. Ratio of I by H. Got it? I by H. Pratigya, do I and S have same unit or different thing?
Same unit.
Same unit. That's why unitless. So magnetic intensity and intensity of magnetization, same unit, looks so similar. Still, when you will solve question, you will face issue in this. Not difficult but confusing. Let me know if you are facing issue. If you don't have magnetic substance, no magnetic property at all, in this case, ability to influence any material is zero. Chi will be zero. Your relative permeability 1 plus psi, same. Your relative permittivity 1 plus psi, same thing. Comparison. This whole chapter is about the comparison with the electrostatic. If you understand electrostatic really well, this is just one of the basic thing. Okay, just basic thing. Any doubt, guys? This is already we did. Let me ask Anvita, what is magnetic field intensity? What is magnetic field intensity?
Sir, I can't remember.
Magnetic field intensity H, which is equal to external magnetic field divide by. What is the simplest meaning? Magnetic field for a given medium or for vacuum. Then that's why if you know this is the value, what will be B value? Nu naught into H for a given medium, nu into H. It is derived from the same formula. Na? Make sense, guys? The revision. NEET is not about learning a lot. It is about revision a lot. Any doubt from this topic?
No,
Observe
sir.
it carefully. See this again and ask your question.
So can you scroll a little bit up?
This one.
Huh. So the time period wala part, can you just explain again?
Time period thing. Again, after completion of the diamagnetic paramagnetic part, I will give you 10-minute time to revise. Then we'll start question. Done?
Yes, sir. Can you explain it like?
Time period.
Sir, I'm not like.
See, here we are correlating with the relation of length and gravity with I and I'm this moment of inertia and MB. If
Yes,
you
sir.
correlate, uh, the one of the easiest way is always compare with the help of the dimension. If this is correct or not. Like we said L by G is equal to I by MB, and we want to know whether it is correct or not. Easiest way is dimension. What is the dimension of L? Length L. Dimension of G, LT minus 2. What is I? Moment of inertia in the rotation chapter is mr square. So dimension for mass will be m, r square will be l square, ml square. And mb is equal to torque. Torque is also equal to r cross f. So r is l and f is mlt minus 2. Correct? So
Yes,
overall,
sir.
it will be ml square t minus 2. If you cancel it out, L cancel, this
Hmm.
L cancel, this L square cancel. Do you have L t minus 2 both the side?
Yes, sir. But then the thing is, it will be only dimensionally correct, no, sir. Because in units and dimensions, there's some formulas that are only dimensionally correct, but they're not actually correct.
Only in the magnitude numbers, number like 1 by 2, 3 pi by 2, these values
Oh,
sometimes do
okay.
not make difference. That's why people feel they need to remember dimension formula. No, it's just some formula look complicated, you can correlate together.
Uh,
Correct?
okay, sir.
You can correlate together. How? Example, I explain this part of dimensional correction. Let's see
Hmm.
second part. How to identify is this correct or not.
Yes, sir.
L by G is equal to I by MB. Let's see what is the I by MB in the different form. I is equal to like mr square from the rotation chapter. MB is like torque, R into F, correct? Mr square, 1 R cancel. Mr by what is the force value? Mg. Isn't it equal to R by G? Or if you write same thing in this form,
Hmm.
now ML square divided by L into F, because instead of R you are taking L. So L cancel. ML by F is equal to mg. Tell me, is this correct?
Yes, sir.
Make sense?
Yes, sir. Makes sense. Thank you.
Hmm. And these are the good thing where you correlate the thing. Oh, I have should have clarity about the rotation motion. Correct? In rotation motion, if you have circular thing, example in the circular ring, if you want to calculate moment of inertia is equal to mr square. If example you have rod and you calculate moment of inertia, it will be equal to ml square by 12.
Yes, sir.
But it always look like this, correct? And that was the question. I'll show you in it because we are left with the last part, paramagnetic diamagnetic thing. Diamagnetic material. Diamagnetic, weakly repelled by the magnet. Weakly repelled by the magnet. The basic thing have you watched this movie? This what is the name of this guy? Mr. India.
Yes, sir.
Person become
Yes, sir.
invisible after wearing a watch.
Yes, sir.
So what was basically this topic about? Though they didn't uh, focus much on the concept of the diamagnetism, because you know how Indian movies look like.
So I
But
didn't
in
understand
reality,
how did you wear a watch and become invisible?
because it is just like kind of diamagnetic material, so it repel all the radiation and person become invisible. Example,
Oh,
person have a watch. This is watch, and this watch repel all the light, electric field, magnetic field lines. It means you in this region can't see anything. It means person will be invisible if person lie in the same region. Correct. Then same thing. Diamagnetism. So diamagnetic material, material that is repelled by the magnet, does not always mean it will be invisible. It's just repelled by the magnet. These are the substance that repel by magnet: copper, silver, gold, NaCl, H2O. because they have almost like fulfilled configuration. They have usually fulfilled configuration, superconductor, perfect conductor, perfect diamagnetism, all electron are paired. In your chemistry, if you are talking about diamagnetism, it simply means a- all electron are paired. All electron are paired. That is simply diamagnetism. Diamagnetism in case of chemistry. Paramagnetism means unpaired electron. Tuhina, tell me, if you take oxygen, O2, atomic number of one oxygen is 8. So total number of electron in one oxygen is 8, in two oxygen 16 electron. Make sense?
Yes, sir.
Tell me, you have even number of electron.
Hmm.
Is it diamagnetic or paramagnetic?
Dia?
Diamagnetic.
Yes, sir.
Sarah,
Yes, sir.
is it diamagnetic or paramagnetic oxygen?
Diamagnetic, sir.
Diamagnetic. Jordan, diamagnetic.
Yes, sir. It is.
It is. Chandana, diamagnetic.
No, sir, paramagnetic.
Why? It is even. It should be diamagnetic.
Sir, it has two unpaired electrons, I think. I remember reading it.
How do we
Sir,
know?
boron and oxygen are
In
diamagnetic.
MOT, I think I read once last year.
Last year.
Yeah, like according to chemistry. Like
Last year.
Sir, in coordination compound.
In coordination compound.
No,
so
sir, no,
yeah,
sir. D
so
block
I don't
D
know
So,
block.
what
so,
chemistry.
so,
number
so,
we
so
have
you
to.
told us it's paramagnetic, two unpaired.
I
Triple
taught
bonding.
2-3 days back.
So I don't
I
remember
remember
triple
now.
bonding.
It's paramagnetic, sir. You
And
told
you did
two
all the
unpaired.
3 for oxygen.
No,
When you have 6 electron, sigma 1s2, sigma anti 1s2, sigma 2s2, sigma anti 2s2, sigma 2pz, pi 2px, and pi 2py. Then pi anti 2px and pi anti 2py. Let's see how to fill electron. Maximum electron 2, 2, 2, 2, 8, 2, 10, 2, 12, 14. Is it paramagnetic or diamagnetic?
Paramagnetic, sir.
And this is very popular question.
So, just
Hmm.
one question related to
Yes.
the Biot-Savas formulation. So, nu naught by 4 pi, we know that nu naught's value is 4 pi into 10 raised to the power minus 7. So, why do we have to take it as nu naught by 4 pi? Why can't we just directly take it as 10 raised to the power minus 7?
Because when experimentally we calculate, example, if we take in the Biot-Savart law, nu naught upon 4 pi. Experimentally, this is the logical value that we get after experimentation. And your new naught value again by experimentation is 4 pi into 10 raised to power minus 7.
Minus 7.
It's like every time when you increase the current, potential will increase. So every time there is one factor that is common. And when we calculate this factor key for a given material in copper, if you take resistance 1 ohm, no, your current, let's take 1 ampere, your voltage is 10 volt. If your current is, let's take 2 ampere, okay, then it will become 20. And if I current is 3A, your potential will be 30. Based on this configuration, what would you tell? What is the constant value? What is the constant value, Jordan, in this case? 10.
10.
So, can you change this constant? Because every time we
No.
are getting the same value for the copper only.
Yes, sir.
So, we get all the constant experimentally when we see, okay, dB, like your magnetic field is changing with changing current, length, radius, and theta. And every time you
Okay.
multiply with a factor, that is 10 raised to power minus 7.
So the constant is basically nu naught by 4 pi. Got it, sir.
Yes. So, diamagnetic material are superconductor, perfect diamagnetism, chi value is -1 and relative is 0. Why? Because you know your relative permeability is 1 plus chi. Chi value is -1 plus 1, 0. So, in this case, your chi value is -1, equal to -1 or less than, more than that. Correct? Relative permittivity could be 0 or less than 1. Correct? Here it is chi value is less than 0. Relative permittivity less than 1. And you know this is always greater in this situation because your nu r is equal to nu by nu naught. If overall value is negative, what will happen? Your nu naught value is more. Nu value will be less. Okay. Any doubt, guys? Is it too difficult to understand?
No, sir.
Hmm.
No, sir.
If it is not for the individual atom, there will be no permanent dipole moment because if there is a dipole moment, there is a movement of charge, then it will be paramagnetic. And it does not depend upon the temperature. Even if you change temperature for the diamagnetic material, it does not matter. And material always move from the strong magnetic field to the weak magnetic field. Strong magnetic field to the weak magnetic field. Chi value is negative, as you can see. Chi value is negative. And if you take, who will tell? Chandana, what is this I and H?
Sir, H is magnetic field intensity.
Correct. H.
Sir, H is magnetic field intensity.
And I.
Sir, intensity of magnetization.
Yes. Intensity of magnetization and H is magnetic field intensity. So this angle is very small and negative. Okay. Paramagnetic almost opposite. Ki diamagnetic repelled, weakly here, weakly attracted by the magnetic. Oxygen is the special case here. Remember, oxygen is the special case here. That's why I'm writing it again. Oxygen is a special case, so is taken here. Okay, oxygen is a special case, is taken here. Many other material, and all these material you will remember with the time. So don't worry, don't memorize the example. But oxygen is important because given in chemistry also. Here you have permanent dipole moment. In diamagnetic, no dipole moment permanently. And here you use Curie law, which says that your chai magnetic susceptibility will depend upon the temperature. In last case, we said temperature independent. Here we said temperature dependent, but in paramagnetic, it is temperature dependent inversely. And value is positive. Psi value is positive. Pratigya, what was the psi value in the diamagnetic material? How many people are there? Brother is there. Sara is also not there. Yes, Pratigya. What is the psi value for the diamagnetic material?
-4.
-1 or remain in minus. Anvita, what was the relative permittivity value in case of diamagnetic material?
Greater than 1.
Hmm? Zero. Zero. It was
Wasn't it more than 1?
zero. In diamagnetic material, what is the relative permittivity? Zero for the perfect diamagnetic. Right?
Yes, sir, my man.
Next. Tuhina, if you compare nu and nu naught, what was the condition in case of diamagnetic material?
Sir, if I compare what and what?
Nu with nu naught in diamagnetic material, what was the situation?
Diamond. Sir, 1 second.
Hmm.
Sorry, sir, there's someone at the door.
Huh.
In diamagnetic, no, sir. I'm not sure, sir.
Nu naught was more than nu. See, nu naught was more than nu.
Yes, sir.
Okay. Here, nu is more than nu. Why? Reason is psi and nu R value. In case of diamagnetism, psi was negative. Here it is positive. There, nu R value was zero or negative. Here it is positive. So nu value will be more.
Yes, sir.
Right? Because we said psi is inversely depend upon the temperature. So it will be parabola. How you draw graph of the P inversely proportional to V, same, correct? Parabola graph. कौन बोला? Parabola. And here this angle is positive. Sarah, how was the angle in case of diamagnetic material?
It was negative, sir.
It was negative. Small negative here, small positive. And material tend to move from the weak to strong magnetic field. Jordan, how was the situation in the diamagnetic material?
So it was the reverse.
What was the reverse? Reverse means what?
I don't explain, sir.
Strong to weak. Yes, it was reverse strong to weak. Now you can do anything by comparing. Example, diamagnetic is weakly repelled, paramagnetic is weakly attracted. Correct. And diamagnetic have chi value minus, paramagnetic plus. Diamagnetic new R value 0, paramagnetic plus. Correct.
So, just two
Individual one have.
questions.
Yes, Jordan.
So, are there any materials which are strongly repelled by magnets?
Yes,
What would they
I
be
will show.
called if they
I will show you.
don't?
Material repelled by magnet. Tell, see, wood, plastic.
So,
Let's
but
see
then,
this.
like, the strength also matters, no?
Yes, it does.
So, will they come under diamagnetic materials or do they have like a separate category because
Diamagnetic
of the
but
strength?
weakly repelled.
Okay, sir.
So
it's not observable because of the strong gravitation. A nail or a piece, very weak effect compared to the gravitational force, so that's why we don't readily observe it. You have probably played around with magnets and found that materials containing iron, like a nail or a piece of steel, are strongly attracted to the magnet. Whereas there's no apparent attraction between a magnet and a piece of aluminum. Now, aluminum is actually paramagnetic, so it is slightly magnetized, and so there is a slight attraction, but that is not observable because of the strong gravitational force. In fact, the relative permeability for aluminum is 1.00021, whereas
more
the
than one.
relative permeability for materials such as steel are on the order of 1,000 or even greater. So you can see that it is a very weak effect in aluminum compared to steel. But I want to show you an experiment that will demonstrate that there is a slight magnetization of aluminum when the aluminum is placed in a magnetic field. I have a variable gap magnet here that produces about a half a Tesla magnetic flux density in the center of this gap. That's a very large magnetic field. I have an aluminum rod suspended from a thread so that I eliminate the effects of gravity. Now, aluminum has a relative permeability just slightly greater than 1, so it will be slightly magnetized and attracted to a magnet. So when I place it in this magnetic field, the aluminum rod will rotate so that the length of the rod is in the direction of the magnetic flux density line going from north to south pole. And if I now take and rotate the magnet, you can see that the aluminum rod will rotate and stay parallel to those magnetic field lines. Also, you can see that the aluminum rod is attracted to one pole or the other depending how I position the magnet. Graphite, which I have a small piece of here, is a diamagnetic material. Okay, so it is weakly repelled by a magnetic field. And I have a thin sheet, and graphite is fairly light. So here's an array of magnets, and if I put the graphite on there, it actually, you can see how it is repelled and actually floats above those magnets. So I can slide this sheet
Can
of
you
paper
see?
right underneath it.
Yes, sir.
Pencil lead is made out of graphite, so if I bring this magnet close enough, the lead will be repelled. Now, I have found that this does not work with all pencil leads, and I suspect in those cases it's because of too high a concentration of magnetic impurity atoms such as iron. So now we have a glass rod suspended from the thread, and glass is a diamagnetic material, so what will happen when the glass rod enters the high magnetic field is that it's going to rotate so the axis of the glass rod is perpendicular to the magnetic field. So you can see how the glass rod has rotated so that it's perpendicular to the magnetic field, and so when I remove it from the magnetic field, it will go back.
Understood, guys?
Yes, sir. Understood now.
Yes. So here it is moving from strong to weak logically in case of diamagnetic, because it is going toward weak because try to stay away from the magnetic field, right? But because in paramagnetic it want to stay close to the stronger, that's why weak to strong. That's why all the value are positive. Ferromagnetism only in the solid because there you have proper alignment of the dipoles. So very strongly attracted by the magnet. You have very strong iron, cobalt, nickel, cadmium, and all this permanent dipole moment, and all the domain are so aligned that there is too much susceptibility, too much relativity, and too much permeability. Correct. So, what is the Curie-Weiss law, which say that the Curie temperature is the temperature above which ferromagnetic material will convert into the paramagnetic material. Temperature at which ferromagnetic material will convert into the paramagnetic material. Nobody will ask you the formula, but Curie temperature is the temperature where ferromagnetic convert into the paramagnetic. Ask me your questions, guys. Everything else is done.
Can you scroll down?
This one.
So can you do like a comparison table for the three?
Yeah, you can write. So I will give you